Welcome to a new AG session all about analytic geometry. Find the length of a median of a triangle at A 2, 3 with a side connecting B 3, -3 and C -1, -1. Before we start talking about what the median is, let's try to plot these 3 points in this Cartesian plane where the horizontal axis is our x and the y-axis is the vertical, and each grid of this would be per one step. So let's try to plot the points here. Let's start with A at 2 and 3. So 1, 2, 1, 2, 3. This is where A is at 2 and 3. Our B is at 3 and -3. 1, 2, 3. This is where we could see our B. And our C is at -1 and -1. Okay, this is our C. If we are going to connect these 3 points, we have here a triangle. Okay, that's AC or CA. That's AB or BA, and this is BC or of course CB. Now we have this triangle now, A at 2, 3, B at 3, -3, and C at -1, -1. We are going to solve for the length of the median. Now what is the median? There are 3 medians in a given triangle. Okay, the median is a line segment drawn connecting a certain vertex and the midpoint of the opposite side. So we are talking about the median of triangle at A. This would mean we are going to draw that segment connecting this vertex A and a certain midpoint of the opposite side BC. Again, it's not perpendicular, it's the midpoint. Okay? Now say for example, our midpoint is here. Example alone. I'm not saying it's correct, but just an assumption. If this is our midpoint, our median now is this line segment here. And we are going to solve for the length. Hence, we are using here 2 different concepts. The first one is the concept of the midpoint. So we are going to solve for the midpoint. Okay, let's have to use this one. It's actually it's a point. So it's a combination of the averages of your coordinates. So you have x sub 1 plus x sub 2. You divide it to 2. That's the x coordinate of your midpoint. And you have here y sub 1 plus y sub 2 over 2. You will have your midpoint, a y coordinate of your midpoint. The second idea is the concept of the distance. Once you're able to solve for the midpoint of segment BC, we're going to solve for the distance of that. Let's say it's D. Let's just call it D. So we're going to solve for the distance of AD or line segment AD using this formula. You have P1 to P2. The distance is computed as the square root of these expressions. You have the difference of x sub 2 and x sub 1. You square that plus the same thing, difference of y sub 2 and y sub 1, and you square that. So these are the 2 ideas that is connected to this problem. So first, let's try to solve for the midpoint. Let's call this midpoint, okay, of segment BC. So this is computed as this expression. So let's try to pick x sub 1 here, or our first point to be point B. So our x sub 1 is 3 plus our x sub 2, which is 4c, is -1 divided by 2. For our y, the same thing. You will have your y sub 1. That's b, -3 plus -1, and divide it into 2. Okay? So our midpoint here is by combining the expressions. You have 3 plus -1 is 2 over 2. On the other side, that's -4 over 2. In short, the midpoint of segment BC, denoted as D here, is equal to the point, or let's not put equality here, it's the point at 1 and negative 2. So more or less, my point earlier is closer to the answer, but it's somewhere here. So that's 1 and 2. Now that we are done with the midpoint of segment BC, let's now solve for the length of AD. So we have here the distance of AD, okay, is equal to, let's pick D as our second point and A as our first point. So our D, x sub 2 is 1, minus our A, the x sub 1 here is 2. And you square that, plus we have here our y sub 2 is negative 2, that's point D, minus our x sub 2, y sub 1 rather, which is a 3, and you square that. So we have here the square root, that's the square of negative 1, plus you will have here the square of negative 5. So you will have here the square root of 1 plus 25. Or in short, the distance of AD being the median of the triangle ABC at point A or vertex A is square root of 26 units. No need to come up with an expression with decimal notation. Since this is an irrational number, we could have this as our final answer. By the way, if you were able to interchange and you choose point A as your point 2, you will have 2 minus 1, that's positive 1. And you will have 3 minus negative 2, that's 3 plus 2, 5. You will still get the same result. So the length of the median AD from A to the midpoint of segment BC, which is known as D, is equal to square root of 26 units. Thank you for watching, and stay tuned for another session here in AG for Analytic Geometry.